Everybody, welcome to Wilkins Workshop. I am going to go through how to create a 1 cup container using Onshape. So we're going to make not really a square cup, but it'll be a rectangular prism that holds 1 cup of material. And we're going to need a few things. The first thing we're going to need is we're going to need to know what is a cup in cubic inches. So that is 14.44 according to Google. So I just typed in dimensions of 1 cup in cubic inches, and there it gives me a conversion factor right there, which is great. I'm going to need my calculator app to do some calculations to get to where I want to go. But here we go. Let's have at it. So if you're new to Onshape, again, I recommend some tutorials on YouTube. There's 100 days of Onshape that are great, but the basics of 3D modeling, if you've never done any 3D modeling before, is you create two-dimensional shapes and then you turn those shapes into three-dimensional volumes or kind of solid features. So um, this right here, all the different things that you can do with a two-dimensional shape. You can extrude it, you can revolve it, you can sweep it. So these here allow you to do those things. And then here's your 2D sketching tool. So we're just going to go ahead and make a rectangular prism today for this cup that we're going to make. So the first thing you do is when you click on the sketch is you need to decide what sketch plane you are going to use. And I'm going to start and build from the base up. So you could start from the side and work in, but I'm a fan of going from the base up in this case. So we're going to click on that top view. You can see that my sketch plane is now there. I will typically click on this over here, so I'm looking at my top view. So now I'm looking at the top, and I'm going to draw a square just in this first quadrant, kind of right over here. And then at this point, I can then say what dimensions I want to use. So I use D as my hotkey, which then selects my dimension tool here. You can see the D in parentheses. I clicked on the line, I moved, and I clicked to drop it. And I'm going to make this 2.5 inches wide. And now there's a couple ways you can dimension this side here. If you want to, you could use the equals constraint. So this right here. And if I set this side equal to this side, again, I'm just left clicking on each of those. It now makes this length equal to this one. So now this is a 2.5 by 2.5 square that I've created. So that's step one. The other thing you could do is you could hit D again for the dimension. You could click on this edge, move over to the side and drop it. You notice it says it's 2.5 because again, we made those equal. And this dimension you'll see is gray because it's a driven dimension. Like I actually can't change that value because I made that equal constraint. Now, if I change this, so I double click, if I made that 2 inches, you'll notice that this also goes to 2 inches. So if I change this back to 2.5, it goes to 2.5. So we have what's called a fully constrained sketch. All of our lines that we want to use are now black, which means that they're fully constrained. I can't click and drag them and move them around in space. Once you're done with that sketch, I'm going to finish it. I'm going to go back to a view, let's an isometric view, where you can see the top right and front. So actually, this is kind of swung around, so I want to see that view right there. So you can see there's my sketch. Now what I want to do is I want to extrude that sketch upward so that I get a certain volume. And the question is how far do we need to extrude it to get to 14.44 cubic inches? So we're going to use a calculator. We're going to take 14.44. We're going to divide by 2.5. Then we're going to divide that by 2.5. And we get a value of 2.3104. So therefore, I'm going to put right here 2.3104. Just check my answer. Looks good. And then I'm going to say OK. And now this cube right there is 1 cup of material. It takes up that much volume. So we did length times width times height, or you could say the width times the depth times the height. It's typically how it's referred to in 3D modeling. And that's for a rectangular prism, that's how you find the volume. So 2.5 times 2.5 times 2.3104 will give us that 14.44 value we're looking for. So how do we turn this into a container? So we can use the shell tool to do that. So there's a shell tool which again, I'm not super familiar with Onshape. My 3D modeling software of choice is Fusion, but they all are very similar in the way that they respond or act. So let's see if we can find where the shell tool is located. There it is. I believe it's right there, shell. So it's going to create a thin wall, and we want to remove this top face, and then we want the shell thickness to be on the outside of the material. So if you notice, it put it to the inside, but if I click on this, it'll move it to the outside of the material. And 0.1 is good. That's a decent shell thickness. You can see we won't go to the outside versus going to the inside of that original shape. So it's going to take the top off. It's going to put a 0.1 inch thick wall around the entire cube that we just had, and we're going to finish it. And now we're ready to 3D print. So I'll have another video on 3D printing and how to export this to a 3D. Actually, I'll show you how to export to get the 3D printing file. And then we'll have another video to show how to import that STL file into our slicer software to then 3D print this particular part. So there we have it. Again, you can make all sorts of shapes and items. So you're not limited to just a square. So if I wanted to go back into Onshape, I want to create a new document. You could do a new document, or you could literally just create a new part studio down here below. I can just create a new part studio, and it will basically allow me to make a brand new part. So let's say I wanted a cylinder this time. So we'll make a quick cylinder. Okay, why not? So we're going to do this. And what dimension should we make that circle? Let's make it a 3-inch diameter. All right. All right, so we've got to go back and figure out what our height has to be for this. So this is going to be, so for a cylinder, the volume is going to be pi r squared times height. So we don't know what the height is. So we're going to take the volume. So we're going to go 14.44 divided by pi. So there's my pi key. Divided by the radius squared. So it's going to be 1.5. And then you could do x to the y and put it 2. So the height is going to be 2.043, basically. We can go to the thousandth of an inch. We don't really have to go to the 10,000th of an inch, but thousandth is good. So 2.043 is going to be my number. So when I do my extrusion on this, I'm going to finish this sketch. I'm going to extrude. And I'm going to do 2.043. Say OK. That's my number. And now here is 1 cup of material. Do the same thing. Click on my shell. Remove the top face. I want the shell to be on the outside. And then I say OK. And now we have another container, different shape. If you're talking about volumes of different shapes, you can have students design, different shaped containers. You 3D print them, and now you have all these different, material or items you can test. So how do we get this to a 3D printable file? So we can go to the part here, and we want to export the part. So click on the part, click on export, and now we want it to export as an STL. And then this one could be a cup cylinder, and my units are going to be in millimeters. That's common for most 3D printers. And then I'm going to download it. So I'm going to hit export. It's going to put in my downloads. See it right there. I'm going to go to this one, and I'll do the same thing here. I'll do a right click on the part, export, STL. Again, this is going to be a cup. It's going to be a rect prism. And then millimeters, and hit export on that. And there we go. There's 2 parts that we've now downloaded as STL files from Onshape. That's how you do it. You can make all sorts of different shapes. Again, you can make cylinders, you can make cubes, you can make rectangular prisms, you can make cones, you can make pyramids, all sorts of things that you can make inside of this software. And it doesn't take a whole lot of learning to figure out how to do some of those things. So there you have it. There's how you can use Onshape. Oh, one last thing I do want to show you about Onshape. I'm going to go back to this part right here, and I'm going to get rid of the shell feature, so it's just the block. Now, how can we see what the value or the size is of this particular cube? Well, some 3D modeling softwares allow you to right-click on it and go to Properties. And in the Properties tab, it will tell you some things about the particular item. It'll tell you the name, it'll tell you the size, might even tell you the density or the volume of that. And in this case, it doesn't have a mass because there's no, it doesn't, we didn't assign it a material. So we have to assign a material to this in order for it to have a mass. So if we click on the material, I think we have to go to another window to do that. Let's see if we, here we go, assign material. Now, you could pick all these different things here to figure out what it is, but I think there's one that's close. This one right here is close. This will probably give us enough of an answer to get us to where we want to be, but this aluminum 7050 has a density of basically 0.1 pounds per cubic inch. See that right there? It's 1 times 10 to the negative first pounds per cubic inch. So it'd be 0.1 pounds per cubic inch. So if I said that that is my my density right there, 0.101, I say, okay, that's my material, and I go back into properties and I calculate the mass. How much should a 14.44 cubic inch item weigh? It should weigh basically 1/10 of that. So you can see right here, this is 1.461 pounds, which is essentially 1/10, because 1/10 would be 1.444. So this is basically, so it's showing that my volume was correct, is all I'm doing. Is I'm able to check to make sure that the volume that I made here is the actual volume that I wanted, is like a double check of that. And then once you know that that's the appropriate volume, I can go in and use my shell tool and again, shell to the 0.1 to the outside of that. And now I've got my part. So those are the things you can do in Onshape to actually check to make sure the part size is correct. And again, depending on the grade level of student you're teaching, you could go from really simple shapes like the ones we just showed, or you could go very complex shapes where they're using scale factors to then scale up or scale down the part that they made so it has the appropriate volume to hold 1 cup. So again, hope that helps. Again, if you have any questions, you can reach out via email. Look forward to hearing from you. Happy making of parts and pieces.